Hello and welcome to this look at transition metals. But this time it's a 6-mark exam question asking you to deduce the formula from some stereoisomerism info and water of crystallization data. So looking at the question as a whole, there's some sections that we can kind of look at one at a time. The first question, or first part rather, says a hydrated nickel-2 complex is heated in a crucible to remove the water of crystallization. There's a clue there where nickel-2 is in the sentence. That means the complex will have a nickel-2 plus ion at its center. So the water of crystallization data can give us the empirical formula and also eventually the moles of water that were removed. But the complex has no oxygen atoms in its anhydrous version. So you can see this from the percentage per mass data. So this means there's no H2O ligands are present in the structure. It says the anhydrous complex B, so this is what's left after you've driven off the water of crystallization, contains a cation C comprising nickel, carbon, nitrogen, hydrogen, which supports the first idea we looked at a moment ago. And it says its 6th coordinate contains 3 molecules of the bidentate ligand D and exists as optical isomers. So basically it's positively charged, but it's a cation. That means that the ligands can't be charged themselves. Its 6th coordinates are likely to be an octahedral complex, like the template I've popped on the bottom of the screen there. So let's work out the masses of samples A and B first. That's the easy bit. So we can subtract them, subtract the mass of the crucible from the mass of the crucible plus each complex, and the difference between those two gives us the mass of water removed, which we'll come on to in a moment. So to work out the formula of the anhydrous salt, we need to divide the percentage by relative atomic mass, making note of which answer is the smallest one. Then you divide everything by that smallest one, and that gives us a ratio that we can use. So this is our anhydrous salt in its empirical form. We need to now update the formula for XH2O. So we need to work out the formula of the hydrated version. So the anhydrous complex has a molar mass of 309.7 grams per mole, and the mass of the sample was 7.433. So using moles equals mass over MR, that gives you 0.024 moles. Looking at the mass of water removed, water has a molar mass of 18 grams per mole, so dividing one by the other gives you 0.048. So it's pretty clear from those two numbers that it's a 1 to 2 mole ratio. So essentially, .H2O needs to go on the end of our final answer. So let's work out the formula first. So there's a lot of hydrogens, nitrogens, and carbons all together. So that would probably suggest something like 1,2-diaminoethane as the bidentate ligand D, which would lead us to a structure like those two, being the optical isomers, and the formula being NiCH2, NH2, CH2, NH2, with a 3 on the outside of the brackets, and then the whole lot going into square brackets with 2 plus, because we know from before that it's a nickel 2 plus ion. And the bidentate ligand has no charge on it, so that charge from the nickel 2 plus remains unchanged. And then we just stick to H2O on the end, which gives us the full formula of complex A. Okay, hopefully this has been a useful breakdown of this question, and thanks for listening. Until next time, see you soon.